Okay, we talked about vertical shrinking and stretching. You grab the ends of the graph, and if you stretch it, you're going to make it closer to the y-axis, versus if you shrink it, you push it down closer to the x-axis. It gets farther away from the y-axis. Now let's talk about horizontal shrinking and stretching. You're given your parent function. You're given a number that's bigger than 0. It's got to be positive. If that number's bigger than 1, and you want to find f of ax, that's a horizontal shrink. It's been shrunk horizontally. If the number is between 0 and 1, and you're graphing y equal f of ax, it's going to be a horizontal stretch. Here's what I find important from this box. If xy is on that graph, the parent graph, then the point x over a comma y is on the new graph. That's important. Last time we multiplied the y value by a. This time we're going to divide the x value by a. You want me to say that again? We're going to divide the x value of the parent function by a. Okay, if I give you the graph of a parent function, f of x, I want you to go graph f of 2x in this example. Can you go graph f of 2x? Okay, in the example, I gave you the point -4, -2. Right here, -4, -2. Up in the box, what did I tell you to do to the x value? You divide it by a. What is a? 2. So I want to divide this by 2. So what's my new point going to be? Let me do it in blue, sorry. Your a value is 2. I'm going to divide the x value by 2. My new point will become -2, -2. Right here. My second point, right here, is at -2, 4. I'm going to divide the x value by a. My new point becomes -1, 4. Right here. The last point is at 2, -2. I'm going to divide the x value by a, and I get the point 1, -2. My new graph looks like this. Can you tell how I picked up these ends here and I compressed it? I shrunk it. Now go see what f of 1/2 x looks like. Yes. All right, given the same parent function as above, I've already listed the 3 points. We need to go get the new points on the new graph. Your x values, you're dividing all of these x values by 1/2 because that's your a value. -4 divided by 1/2 is -8. So your point becomes -8, -2. No, right there. Your second point here is going to become, what's -2 divided by 1/2? Your second point becomes -4, 4. Right here. And your third point If you divide 2 by 1/2, your third point becomes 4, -2. So your new graph looks like that. Questions there? So you grabbed these points and basically stretched it out horizontally. Okay, I think we did reflections already, yes? Yes, we did it out of order. Okay, summarize transformations of graphs. This is everything we've done in this section. Here is your parent function, y equal f of x. What are all of those parent functions? You had y equals x. You had y equals a number. You had y equals x squared. You had y equals square root of x. You had y equal x cubed. You had y equal cubed root of x. You had y equal absolute value of x. You had the reciprocal function y equals 1 over x. And you had the reciprocal squared function y equals 1 over x squared. Those were all of your parent functions. What did we do to those parent functions? We did vertical movements. If you added a number out to the side of your parent function, that moved it which way? No. It moved it up. If you added a number outside of the parent graph, like x squared plus 7, it goes up 7. If you had something like x squared minus 7, that moves it down. If you had, with the x value, say x minus 2 cubed, x minus 2 cubed goes to the right. If you had x plus 2 quantity cubed, that would move it to the left. Then we had vertical shrinking and stretching. You did a times the parent function. If a was bigger than 1, you had a vertical stretch. If a was between 0 and 1, you had a vertical shrink. If you did f of a times x, if a was bigger than 1, you had a horizontal shrink. If a was between 0 and 1, you had a horizontal stretch. Last but not least, the reflections. If you stuck a negative out in front of the parent graph, like negative x squared, everybody with your arms, you say x squared looks like this. So what does negative x squared do? It drops it down. It reflects it over the x-axis. If you did f of negative x, so the negative's inside with the x, that flips it over the y-axis. So what does the square root of x look like? Everybody with your right arm, you go like that. So what does negative square root look like? Negative's out front. Which way is it going to drop? That way, down. Okay, where's square root of x again? What does square root of negative x look like? Okay. All right. Steps for graphing multiple transformations. Use the following order. Shift it horizontally first, then do your stretches, then do your reflections, then do your vertical translations. Or, here's an idea. Why don't you just go graph it on your calculator? Let's go do one. Go do your parent graph first, then start messing with it. For my parent function, y equals x squared, my three favorite points are -1, 1, 0, 0, and 1, 1. You with me? What do I do first? What does the box tell me to do first? Horizontal shifts and then reflections. Okay, let's go look at the three things we need to do to this graph. Do you see the horizontal shift here? Which way am I going? I need to go right 4. Do you see this one? What's that going to do to it? It's going to go up 3. And then I just heard somebody say reflect it. The negative out front reflects it over the x-axis. Perfect. Those are the three things I need to do. What order do I want to do it in? I want to do blue first, then pink, then green. You agree? So let's go do them all in order. Right 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oops. So, with my horizontal, I'm now there. Then I want to reflect it. Take the blue one and reflect it over the x-axis. With my reflection, I'm now there. One more thing to do to that graph. The green, move it up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. The graph I want is that green one. From the parent red one, I moved it right 4 in blue. Then I reflected over the x-axis in pink. Then I moved it up 3 in green. It's a process. Let's go practice again, right? Did I do one more? Yes. Okay, what is the parent function? And then I'm going to pause and give you a break. What's the parent function on this one? 1 over x, the reciprocal function. I only gave you 2 points on that one. I gave you -1, 1, and 1, 1. And it's in quadrants 1 and 3. You need to do 2 things. There's a horizontal shift with the x. How much in what direction? Left 2. Because it was x plus 2, I'm going to go left 2. After you move everything left 2, you need to move it down 3. When you're graphing it, make sure your denominator is in parentheses, 1 over quantity x plus 2, and then do -3. The graph. The red is the 1 over x. The blue has been moved left and then down. How much left do you move it? 2. So this point's going to become here, and that point's going to go there. My new asymptote is there. Asymptote. Isn't that a fun word to say? Okay, so that moved it left 2, and now I need to move them down 3. 1, 2, 3. 1, 2, 3. You good with that? Sure, why not? Y'all are going, no. I don't understand a thing. I'm going to quit recording and we're going to go get an activity and practice some.